Alright, finally, what I wanted to show is the 4 more common ways of dealing with declination. And I'm going to tell you right off the bat that 2 of them are much highly preferred, but you'll see that, I guess. The first one is math. This method, in my mind, is highly discouraged, just because it ends up getting a little bit complicated. I mean, there's rules out there, I'm sure most people have heard them, whether or not you add for east declination, or add for west declination, or subtract for east, and little sayings to help you remember that. But the difference is that when you take a bearing with your compass and transfer it to your map, or take a bearing from your map and then want to put it to your compass, you gotta flip-flop those, and when you add in one direction, you subtract the other direction, and it just gets very confusing, especially when you're dealing around the 360 degree range. You've got 13 degrees declination. You're going from compass to map, and you got to try to scratch your head and figure out, do I add or subtract? And you're 2 hours late for camp. It's dark, and all you can think about is a hot meal, and you're cold. I'm just telling you, just forget about the math. And you'll be convinced when you see the other 2 methods. The other one is called drift method, or drifting the scale, and it's a pretty easy setup to do. I guess it's better for your backup compass. I wouldn't use it all the time, but what you see is on this is a cheap compass. Underneath the doghouse there are little red markings that show declination for east and west. I'll zoom in there. Okay, so you can see those. And what the idea is you know what your current declination is for the area. And my area happens to be 6 degrees west. So instead of pointing the needle in the doghouse, you point it to line up with that 6 degree number. Now, like I said, this works well for a backup compass or whatever, but the problem is that you always have to remember your declination every time you go to use your compass, and you always have to remember to point it there as well. So there's just a lot of remembering going on. But it is a valid method. Next method is make map, speak compass. What I mean by that is that your map generally has north-south lines on it. It's speaking true north and south. Your compass, on the other hand, is pointing towards magnetic north. It's speaking a different language. So what you want to do is, in the make map speak compass method, is go ahead and put the magnetic lines on your map. And the easiest way to do that is to take your map. You know what your current declination is. I said again, mine's 6. So I'm going to move my compass bezel 6 degrees to the west. Okay, which in this case is actually subtracting from 0, and I'll explain that in a minute. So what you do is you line up your meridian lines in the capsule with the north-south lines on the map. Then when I strike a line, there we go, it is pointing towards magnetic north, which is 6 degrees west of true north. Now if I look at my little declination diagram down here, and this is why I say don't try to remember the rules whether or not I added or subtracted. If I would have drew a line and it went off this way, if I look at my little diagram down here, it shows what side of true north magnetic north should be. So this one is indeed going that direction, so I knew I drew it right. If I just would have set my compass to 6 degrees and then did it like that, I would have drew a line going the other way, and then looked at the diagram and said that's backwards, I did it wrong, I need to take off 6 degrees. That's why I usually don't try to remember all the rules for doing that, because it's pretty obvious based on the declination diagram. Once you do that, you can take a longer ruler, back this out, continue that line the whole length of the paper, and then if you want, without moving it, you can just strike the other side so you know that they're parallel, and then just keep moving it along until you do the whole page. If you happen to have one of these fancy things, a parallel rule, you can just slide it along and do them that way too. One warning that I do have to give, that I strongly encourage you to listen to, is the declination diagram. I've seen methods where they say to reference the declination diagram in order to do these magnetic lines, and that is highly advisable not to do that, just because separate different maps are done differently, and a lot of times this diagram is just a graphical representation of what is really occurring. By this magnetic north being to the left of the true north, they are showing that you do have a west declination, and sometimes it's not, they may say 14 degrees, but it might not always measure 14 degrees. And this particular one, this particular graphical representation might be put on 3 different maps, showing 17, 14, and 12 degrees declination, just because they don't normally intend you to use this as a measuring device. And here's a perfect example. If you look at grid north, if I happen to be working off grid north, it's showing me that grid north is less than a degree off of true north. Now, if they truly drew that to scale, I'd have 2 lines on top of each other, and I wouldn't even see that line. So what they had to do is bump this out, and this line is really laying at 4 degrees versus less than 1 degree. If I just start orienting my map off that line, it's just going to get me in trouble. So use this for what it is, a graphical representation. I would put the lines on the map in the manner that I drew them on, and actually measure them yourself. Because the other thing about the declination diagram is, if you look at this right here, it says UTM grid and magnetic north declination at center of sheet from 1978. Okay, this is a brand new map. I just bought this one. And as much as we'd like to go out and get the latest versions, and you do get the latest versions, it's possible that these have not been updated for 20 or 30 years or even more. Updating government maps is not high on the priority list. So this 14 degrees is possibly even off by another 2 or 3 degrees, because, as we know, magnetic north is moving. There are websites and things that you consult to get current magnetic declination, and that's what you should use when you are actually scribing your lines on your map.